We have, of course, seen this in different forms already. But anyway, sometimes in our problems we'll get two or more rates in the question we have to deal with, and we've got to link them together to come up with what we want, and we're using that basic idea. Implicit differentiation, call it whatever you like. HSC question. A stone drops into a pond, creates a circular ripple. They've told us how the radius is increasing. It's at a constant rate. They want to know the rate at which the area is increasing. So we want to find dA to t. So what information have we been given? We've been given this constant rate of dr to t is 5, but we want dA to t. So if I could come up with a relationship between A and R, then we could work out dA dr and we'll be okay. Well, of course, we do have a formula that links area and radius together. And if I differentiate pi r squared, we get 2 pi r. So subbing all that in, we now have a formula for dA to t in terms of the radius, 10 pi r. Our question was when the radius is 15. So when r is 15, we end up with 150 pi. So we answer the question, there it is. The ripple's area is increasing at a rate of 150 pi. And the units for this, of course, would be centimetres squared, its area, and per second was the time unit we were using. This one was a nice one. We had this Ferris wheel. It's got a radius of 20, rotating at a rate of 1.5 radians per minute. The top of the carriage is 8 metres above the diameter, and they've given us angle of elevation is theta. Okay. First of all, to help us out, they said, look, work out this. What is dh to theta? So we need to come up with an expression that links h and theta together. We've got a nice right angle triangle there. So h over 20 is sine theta. H is 20 sine theta. dh to theta is 20 cos theta. What speed, notice I've asked for speed, not velocity, is the top of the carriage rising when it is 15 metres higher than the horizontal diameter of the Ferris wheel? Okay, so we're trying to find dh to t. We just worked out dh to theta. Can we link theta and time? Well, yeah, they gave me that information. To theta to t was 1.5. I've written it as a fraction, but 3 on 2. So we should be able to create dh to t. Let's sub all that in, and it's 30 cos theta. Unfortunately, they've asked it when h is 15, so we haven't got theta yet. So we're going to have to work that out. When h is 15, there's the triangle. What would happen, the radius is a constant 20, with 15 above the diameter. That means the adjacent side, because we've got to find cos, is the square root of 175. We could do an exact value as well. They said to 1 decimal place, so I guess that's why I did an approximation there. 19.8 metres per second for that one. The next year, 2019. So distance A is inversely proportional to distance B. Now you should of course know what inversely proportional means, but they have given you a bit of help here. Remember A equals, they've also told us the constant, I guess, so 9 over B. The two distances vary with respect to time. Distance B, they've given us the rate. We want to find the rate of A's changing when A is 12. So dA to t is what we want to find. We have dB to t. We've got an equation that links A and B. When A is 12, B is 9 on 12. There we go. In fact, they gave me dB to t, so I can sub straight in. And we got minus 16 on 5 for that one. So A's decreasing, because it's negative, at a rate of 3.2 metres per second. So that's a recap of our rates of change.